Hi, welcome back to Mr. Slover's Math, and today we're focusing on graphing linear functions. So it says we can graph lines in slope-intercept form. So up top we got the warm-up. This is getting us ready for graphing. It says what is the slope and y-intercept of each linear function. Remember, we're focusing on the equation y equals mx plus b, where m is our slope and b is our y-intercept. So m is our rate of change. This first one has a rate of change that's 2 over 5. That means we're going to go up 2 and then right 5 each time on our coordinate plane. And then the b is where our function crosses the y-axis. In this case, it's going to start at 4 on the y-axis. Now, when we look at the next one, it says f of x. That's just a fancy way for us to say y equals a half x minus 3. Later in your mathematical career, you may have different functions, and in order to denote those different functions, instead of always calling them y, they could be f of x, or they could be a g of x, or an h of x, or whatever the case may be. But it's just a fancy way for us mathematicians to write the letter y in this case. I want to draw your attention to the last two. So this one says y equals negative 2x. There's nothing after that x. There's no b value. So there's no b value, it's a 0. And that's okay, there's nothing wrong with that. And this one says g of x equals x minus 2. Now, how did we know that our slope was 1? Well, the coefficient of that x, whether we see it or not, we know it's a 1. It's always there because it's saying x. Well, that's the same as 1x. So our slope for that one is 1. Here's just some quick reminders about graphing. So the first one says step 1 is we got to make sure the equation's in slope-intercept form, which is y equals mx plus b. So if it's not, you need to get it into the slope-intercept form. Step 2 is we got to start at the y-intercept, which is on the y-axis. So once we have that point, then we're going to go to step 3, and we're going to use the slope, which is the rise over the run, to get the next point, and the one after that, and the one after that. And we're going to connect those dots and make sure we put arrows on it, because our line goes infinitely in whichever direction it's pointing. So here we go. We got some examples. So we've got y equals 2/5 x plus 4, and these actually should look familiar because these came from our warm-up. So my y-intercept is 4. So on the y-axis, I put a point at 4. And then my slope is 2/5, which means I go up 2 because it's positive, and then right 5. So from this point, I go up 2, right 5. And if I wanted to, I could keep doing that. I can go up 2, right 5. The more points you have on your graph, the better accuracy you have. For letter C, now my slope was 1. I chose to write it as 1 over 1 because remember, any number you can put over 1. I can write 7 and put it over 1. It doesn't matter. In this case, I have 1, and I'm going to put it over 1. And the reason I'm doing that is so I remember that my slope is a ratio of two things. It's the rise over the run. So I have 1 means I'm going up, and then I also have 1 on the denominator, meaning I'm going right. So me writing as a fraction is reminding me to do two different things, to go up in this case and right. So down here on example 2, notice that these are not in y-intercepts form. I need to solve for y equals mx plus b. So here's just some examples. You can work through this, you can look through this. But I want to talk about the special cases. So we all know math has those weird special cases that are different than everything else. They don't necessarily follow those rules. So this one is what this is. So example 3, it says state the slope. Well, this is a vertical line. If it's going up and down, it's a vertical line, which means my slope is undefined. Okay? I'm not going, and if you were to do this mathematically, you could count you went up 4 maybe, but you didn't go right or left, so you're over 0. So 4 over 0, you can't divide by 0, so our slope is undefined. Likewise, for letter B, now I have a horizontal line. Our slope is 0. Okay? I can't go up or down, right? So my numerator If I was using the y2 minus y1 over the x2 minus x1, my numerator would be 0, my denominator would be some number. 0 divided by whatever number is 0. Okay, in high school, I remember the difference by horizontal was like the horizon, going left to right. Horizon is spelled with an O, which looks just like the number 0. So that's how I remembered it. I don't know how you're going to remember it, but that might help. And then here's just some examples. So y equals 8. So on the y-axis, it says y equals, it's just a constant. There's no other variable, just a constant. Y equals a constant. On the y-axis, I go up 8, and I'm going to go left to right. It's a horizontal line. Letter C says x equals, and it's just a constant. X equals -3. So on the x-axis, I'm going to go to -3, and I'm going to go straight up and down.